Okay, so in this video, we will be continuing our series on the doubly linked list data structure, and we'll be covering two concepts or operations that one can perform on a doubly linked list, namely how to add a node after a specified node, and then the related operation, how to add a node before a specified node. And so what we'll do is we'll cover each of these concepts individually, and then in between, after we cover the relative concept, we'll go over to Python and code it up to see how we can actually translate that idea into code. So the first one that we'll consider is how to add a node after a given node in a linked list, a doubly linked list. So this, let's say, is our doubly linked list, and let's say that we create a new node that is specified by a data element, which we'll call E. And the next piece of information we'll need to know where to put this. So we want to add this node after a node in this doubly linked list that's specified by a given key. So in the case where, let's say, the key is B, we traverse this linked list, this doubly linked list, looking for the node that contains data element B. And once we find that, our goal is to add the new node that we've created after the node with the key. So we want to put this in between B and C in this case. So for adding after and also for adding before a node in a doubly linked list, there's really two specific instances that we want to take care of. Let's cover the first, possibly easier instance of adding an element to a doubly linked list. Let's take the following example. Let's imagine that we have a doubly linked list with only one single element, and we want to add a node that's given by this new node that we have floating here in this random space. We want to add this node after the node A in this doubly linked list. So in this case, what we'll do is we'll start off at the head of the node, and we'll ask, is the head, does that contain the data element that we want to add after? Namely, does the data element stored at the head contain the key? And if it does, and if it is the head of the list, then what we can do is we can actually make use of one of our functions that we coded up in a previous video, namely the append function, and we can simply append it onto the end of this list. So we can just make a simple call in the case where the node that we want to add after is the head. We can just call the append function, and that will do the trick. So that one is relatively straightforward, especially after we've already coded up this append function. The one that's a little bit more tricky or a little bit more involved is when we have, let's say, a list with at least more than one node, and we want to add a new node after a given node with a key. So let's take another example. We have a complete list here, at least a node with more than one node. And what we want to do is we create this new node here based on a data element that we're given, in this case E again. And our goal is to add this new node that we've created after the node in this doubly linked list that contains data element B. So what we do is we want to start off at the head of the list and just keep going until we hit null, all the while looking for whether or not the node that we're on contains data element B. So for instance, we start off a pointer here at the head, we look at the data element there and check that it's not equal to the data element, the key that we're after. We move on to the next pointer traversing the list, we check the data element stored at this node. It does turn out to be the key, which is the one that we want to add after. So what we do is we say we found this node that we want to add the new node to after, and that's going to involve doing a few different things. We essentially need to change some of these arrows around. So because our goal now is to wedge this new node that we've created in between B and C. So some of these next and previous pointers need to be updated accordingly. So let's just go over what needs to happen there, and then we'll see how we can translate to Python code. So the first thing that we need to do is once we've found this node here, once we've traversed the list and found it, we need to update the pointer. So let's update the next pointer to not point to this one anymore, but we need to point it to the new node. So likewise, we also need to update the next pointer of this new node to point to what was previously the next node of this guy over here. So we've kind of got this next structure here starting from B to E to C, but since this is a doubly linked list, we want to make sure that we also get the previous pointers updated as well. So the first previous pointer that we need to update is now C doesn't point back to B, but C should point to E. So we update the previous pointer there, and there's one more pointer that we need to update, and that is the previous pointer from E to B. So that's going to give us this. So we've added E successfully within our doubly linked list. So we have A, B, E, C, D, which is what we want. And that's pretty much the general idea of what we want to do when we add a node after a given element in the doubly linked list. So what we'll do is we'll start back here. We'll actually start back here and we'll code up each of these scenarios, each of these really two main scenarios in Python, and I'll refer back to the slides periodically to touch on some key points as to what we're doing. So let's minimize this and let's go to our code. So I've already added prototypes, namely add after node and add before node, and you can see that they both take similar arguments. So they take self, which because they're part of the doubly linked list class that we've been working on, they take a key. Again, the key is the element in the doubly linked list that we want to add either after or before. And then the data. The data is going to specify the new node that we create, and that's going to be the data that's going to be the node, rather, that is created from the data that's going to be added either after or before the node with the key that we're seeking. Okay, so right now what I have here is I have a doubly linked list with elements 1, 2, 3, 4, and we will be playing with that doubly linked list as we fill in these functions. So let's go ahead and add in the logic for adding a node after a given element in a doubly linked list. So remember, what we can do is we set the pointer, let's set a pointer equal to the head of the list. So we'll say current is equal to self.head. And then what we do is we move that pointer all the way through the doubly linked list until we hit null. And there's two cases that we want to check. So we want to check if current.next is null and the data element at that point is equal to the key. So let's put a pass there. So what is this actually asking? This is asking, while we set the current pointer to the head of the list, if it so happens that the .next is none and also the data at that point is equal to the key, that's going to be equal to this case right here. .next is none, and the data element at this point, which is the head, that is the one that we're after. So basically, if this situation occurs, remember, all we need to do is create that new node. And then once we create that new node, we can just append it onto the end of the list because we're adding after this head node here. So let's go ahead and just call the append function. We can just say self.append data, and then we can return, so that way we break out of that while loop. So now let's go ahead and consider the else case. So else current.data is equal to the key. So, or rather else if. So else if current.data is equal to the key. So if we go along and the node that we're on is not equal to the head and it has the key that we're after, then we're going to want to add the node that we create from data element after this node with a key. So for instance, that would be, let's say this case right here where we're on B, this is a node in the list, and we want to add this new node that we've created after this node with the key B. So what we want to do there is we want to first create the new node. So we'll say new node is equal to node of data. And then what we're going to do is we're going to create a pointer to the next of current. So we're going to say this is current, and we want to create a pointer to this guy over here, because essentially we want to reorient these arrows in such a way that points properly to E. So let's go ahead and create a pointer to this guy over here, and then we'll manipulate these arrows in such a way to get us to this point here where we have the arrows pointing in the proper orientation. So let's go ahead and do that. We'll say next is equal to current.next. So again, this is just a pointer to current.next. It's a pointer in the example in the slides to the node that consists of the data element C. And then what we're going to do is we're going to say current.next is equal to new node. So what is that doing? Let's go back to the slides again. So we're here. We've created a pointer to this guy over here with C. And then we're saying current.next, so again, that's this guy over here, current.next is equal to new node. So instead of the next pointer pointing to C, we want to point that to E. So current.next points to C. We want to say current.next should point to E instead. So we've done this operation here. So we've updated the next pointer of current to point to this guy here. The next thing we want to do is we want to update the next pointer of the new node as well. So we want the new node, let's just go back to the slides. We want the new node to point to this guy over here. So we want to say new node.next is equal to the pointer to that thing that we stored, to the next variable that we stored. So again, we have this variable that we created, nxt, which was a pointer to this guy over here. So we want to make sure that the new node.next points to that pointer, points to this node over here. So we'll say new node.next is equal to the variable that we created up here. Okay, so we're almost there. We've got to update the previous pointers now. So what we want to do now is we want to change the previous pointer of this guy over here to make sure that it points to back to E. And then we also want to make sure that we have the previous pointer of this node over here pointing back to B. So in order to do that, we can say new node.prev is equal to current. So what that's going to do is that's going to take the previous pointer of this new node and point it back to B. And then we also want to make sure that we update the previous pointer so that C doesn't point to B. The previous pointer of C doesn't point to B, but it points to E instead. So what we want to do there is we want to say next.prev is equal to new node. And then as we move along in this while loop, we want to make sure that we update the current pointer from head all the way up till null. So we'll say current is equal to current.next as we're moving along in this loop. So that should pretty much do what we need for adding after a given node. Let's go ahead and test this out to make sure this performs as expected. So again, I have this doubly linked list with elements 1, 2, 3, and 4. Let's go ahead and try to add add 11 after node 1. So let's say doubly linked list dot add after node, and we want to add it after the key. So the key in this case is 1, and we want to add a node that's created from the data element, let's say 11. And then what we're going to do is we're going to print out the list that results from this. So we should see 1, 11, 2, 3, 4. Let's go ahead and make sure that we see that. So indeed we see 1, 11, 2, 3, 4. Let's go ahead and try a few other ones. Let's try to add 12 after 2. So we'll say doubly linked list dot add after node. Let's say the key is 2, and we want to add 12 after that. So again, we should see 1, 11, 2, 12, 3, 4. So let's make sure that we actually see that. So 1, 11, 2, 12, 3, 4. And then let's just add 1 finally onto the end of the list. So let's say doubly linked list dot add after node. We'll say 4, and let's add 14. So again, we should see 1, 11, 2, 12, 3, 4, 14. Let's make sure that we see that. And indeed, we see 1, 11, 2, 12, 3, 4, 14. So that seems to work as expected. So let's go ahead and code up the second function, which is add before node. Before we do that, let's go through the logic of how we can think about that. It should be pretty familiar, especially after having gone through the adding after node in this doubly linked list, but we'll go through the slides all the same just to make sure that the concept is a little bit more clear. So let's go back to the slides and let's go to adding before a node in a doubly linked list. So again, we have this doubly linked list and we want to create a new node and we want to add it before a node instead of after it. So again, there's really two cases that we want to consider for this scenario. One is the case where we only have one node that is the head of the list. And in this case, what we want to do is we want to make sure that we create the node and then we add it to the front of the list and we update the head pointer to point to the new node that we've just added before this guy. So we already have a function that does that, and that is the prepend function. So if we just have a doubly linked list that's given by something that looks like this, where it only has one node and that node is a head, then all we need to do in this case is we can just call the prepend function, and it does all of the necessary steps. Namely, it makes sure to update the next previous pointers of the new node that we create, adds it to the front of the list, and then updates the head. So that is from just like we did for the append function for this case for adding after a node, we're doing a similar thing here for adding before a node. So again, that append and prepend functions, those are in a previous video in this doubly linked list series, so you can refer to that video as well if you want to see how those functions are implemented. The functions prepend and append are also provided in the code that we're writing, and the code that we're writing is always hosted on the GitHub page as well, so you can refer to it there as well. So that's an easy case. The slightly harder case is adding it before a specified node. So, but this follows a very similar flavor to what we've seen for the add after node as well. So let's again assume that we have a doubly linked list just like this. We have a new node that we create, and we want to add it before a given node. So for the sake of argument, let's just say that the node that we want to add before is the node with key B. So we traverse the list, we find the node with data element B, we found our node, and we want to add the new node that we create before that node with the key, in this case B. So in that case, we follow a similar type of trajectory, namely we need to update the arrows, these pointers, in such a way to wedge E between A and B. So first step is we need to update the next pointer of this person here, this node right here. Make sure that next doesn't point to the current, but next should point to the new node. Likewise, we want to make sure that we update the previous pointer of the current node as well. So we update that to point to the new node. And then two other arrows need to be added. Namely, we need to make sure that the next pointer of this one points to B and the previous one of this one points to A. So indeed, next points to B and previous points to A. So we have the proper doubly linked list structure where we have A, E, B, C, D. So that's kind of the general idea. Very similar, should look reminiscent of what we've seen when we added after a given node. But again, just for the sake of completeness, let's just go through this and code it up in Python and see if we can get it to properly behave. So again, prototype is written, add before node, same exact prototype as add after node, and let's go through each of those two main cases for this scenario. So again, we'll have a pointer which we'll call current, which will initially be equal to the head of the list, and then we'll say while current, so while it's not equal to the end of the list, it's not null, we're going to check if current.previous is none and current.data is equal to the key that we're after. So again, this is the case where, just go back to the slides, this is the case where we have something that looks like this. Previous is none, and we want to essentially add the node with the key that's equal to the head before this one. So this is the new node. We want to add it before the node with the key that corresponds to the node that is the head of the list. Let's go back to the code. So again, in this case, we're going to have a very similar type of thing, only instead of calling append, we're going to call prepend on this. So prepend data, and then we're just going to return because we're done with that operation. So again, we're going to have an else if statement where we move along in the list and the node that we're after with the key is not the head element. So otherwise, if current.data is equal to the key that we're after, we're going to do, well, we're pretty much just going to update those pointers. So actually, let me also put in right here, current is equal to current.next. So I remember to do that outside of the if statements. So right, so at this point, let's go back to the slides. We're in a scenario like this. We create a new node here. We want to create a new node here, and we want to say add it after the node in this doubly linked list with key B. So first step is let's go ahead and create that new node. So what we'll do is we'll say new node is equal to node of data. So we've created that new node. And then what we want to do is we want to store a pointer much in the same way that we stored a pointer to current.next up here, so we can manipulate that pointer. We want to do a similar thing for the previous one in this case. So we'll say prev is equal to current.prev. So we're storing a pointer because we're adding before, remember? So we want the information of this guy because we're moving these arrows around. Before we stored a pointer to this node over here. I keep calling these nodes people. They're not people, they're nodes. We wanted to store a pointer to this thing over here. That's because we're adding in between these things. We're moving this thing in between these guys. So we want to make sure that we have a pointer that points to this thing so we can manipulate these pointers, these arrows in such a way that gives us the orientation that we're after, namely this one right here. So let's go back to the code again. So we stored a pointer to the previous node of the current, and then what we want to do is we want to say previous.next is equal to the new node. So what is that going to do? So let's go back to the slides here. So it says previous.next is equal, let's just go back to the code and just verify previous.next is equal to new node. So previous.next, this is the previous one, remember? So previous.next is equal to the new node. That makes sure that the next pointer of the previous node points to the new node. So what's next in the list? We want to make sure that the previous of the current, rather this one right here, points to the new node as well. So we want to update that pointer as well. Let's make sure that we do that. So we have previous.next is equal to new node. And then what we want to do is we want to say current.previous is equal to new node. So again, what that's going to do is that's going to essentially write this arrow from current.previous is equal to the new node. So now this arrow points to the new node. Okay, so what's next in the slides? So next what we want to do is we want to update the next pointer of this new node to make sure that it points to this current right here. So new node.next should point to current, right? So let's go ahead and do that. New node.next is equal to current. And then the last thing that we want to do is we want to make sure that since this is a doubly linked list, we need to make sure that the previous pointer of this one goes back to this guy over here. So we want to say new node.previous is equal to previous. Again, the pointer that we had to this node over here. So we want to say new node.prev is equal to prev. Again, that's this pointer that we stored up here. And that will pretty much do it. So let's go ahead and verify that this works as expected. Let's go ahead and instead of adding after, let's go ahead and change this to before. So let's just make sure that we can add before these nodes. So again, the same idea. We want to, before the node 1, we want to add 11. So we should see 11, 1. And then again, we want to see 12 be added before 2 and 14 be added before 4. Let's just go ahead and verify that all of these functions work as expected. So 11 is added before 1, 12 is added before 2, and 14 is added before 4. So it seems to work as expected. So that pretty much does it for this video. If you have any questions or comments or anything of the sort, please don't hesitate to leave them in the comment section below. As always, the code for these videos is provided on my GitHub page, and that link is provided in the description to this video. Thanks again for watching, and have a great day. Bye.